I'm going to let you guys do this one. We're going to go step by step, though. So, first of all, I need you guys to put your data in order, and then I want you to find the range. I'll give you about a minute. Okay, 9 is the correct answer for the range. High minus low, 10 minus 1 is 9. Okay, next I'd like you guys to find the median, please. So, let's see what the median is. We're going to have Mia tell us. Mia, what'd you get for your median? 2? That would be for your first quartile. You're right. But right now I'm looking for the median. Can somebody help me what the median is?
4.
It's 4. Why? Because we had 2 numbers in the middle, and if you average them, you'd get 4. Now we're going to do the quartiles. Now I wanted to stop and do a quick disclaimer on this. Do I have an odd number of terms this time or an even?
Even.
And when there's an even, we include the 2 numbers that were involved in the process. So here's your lower half. Notice I included the 3. And here's your upper half. So now I'd like you guys to find the quartiles using those 4 numbers. So when we found the first and third quartiles, just like with the median, if you don't have a number dead smack in the middle, then you have to average the 2 that are in the middle. Now we're going to go ahead and have you guys draw a box and whisker plot. So you have your minimum, your maximum, and your median, and the 2 quartiles. Go ahead and plot those and make a box and whisker plot. Dots here. So we're going to go ahead and do this box and whisker plot. A number line going from 1 to 10 should be good. So Sharon, tell me where the dots are going to go. 1 for the minimum. 2 for the first quarter. 4 for the median. 6.5 for the third quartile. 10 is the max. And then we draw a whisker on the last 2 dots and the first 2 dots, and then we do a box around the middle 3 dots. And the longer your box is, the more your central data is spread out. The closer your box is, or the smaller it is, that means the more tightly packed together your central data is. So it's just a way of examining how data is spread out. Okay? Okay, guys, well, that's like a few ways you can look at how data is spread out. You can find your quartiles, and you can find your range, and you can even make a graph of it. Now, you don't need to write this, but just for your information's sake, which set of data has the greater average distance from the mean? Now, that's a lot of words. What has the greatest average distance from the mean? So what does that mean? Average distance from the mean for you. So basically, from all the answers I was getting from you guys, it has something to do with how much the data is spread out, right? Well, this is saying, on average, how far is each number away from the mean? So if we found the middle number, the mean in this case, not the median, but the mean, if we found the mean, and we found out, well, how far is each piece of data? Well, this one's maybe 1 spot away, this one's 2 spots away, next one's 3 spots. You find out how far each one is away from the middle. You find the average of all those distances. That's another way that you can tell how much your data is spread out. If the average distance from the middle is a big number, well, your data is super spread out. If the average distance from the middle is a smaller number, well, that tells you your numbers are pretty crunched close together, right? So that's what we're going to be finding here, is the average distance from the middle. Now let me ask you guys this. If I asked you to find the average distance of the middle, what would you have to find first? You need to find the middle. And then if you want to find out how far each one is away from the middle, what would you do? You would take each piece of data and subtract it from the middle to find out how far away it is, right? And then if you want to find the average of that, you would average all those distances, correct? That's kind of like what we're going to do. I'm going to do a few weird mathematical moves in here, and I'll explain them as we go. But that's about what we're ready to do. It's called standard deviation, all right?